Depict the galvanic cell in which the reaction zinc solid plus 2Ag plus giving you zinc ions plus 2 silver takes place. Okay. And further show which of the electrodes is negatively charged, the carriers of electric current in the cell and individual reaction at each electrode. So we are supposed to construct a simple galvanic cell of what is called as metal-metal ion electrode, and we are supposed to discuss and explain that. That's a very beautiful and fundamental question, and this is one question, if you understand this properly, your initial fear of electrochemistry would be substantially reduced. Are you ready? There we begin. See, what I've drawn here is just to save time, I've pre-drawn it. It is a simple vessel in which I have some liquid, some solution and a rod. And what is this? If you have zinc and zinc ions, always remember, metal has to be kept dipping in the solution of its own ions. Its own ions, nobody else's ions. So if you have a zinc rod, then zinc rod has to be dipped in a solution of zinc ions. Silver ions and silver. So this has to be silver metal. Then this solution has to be Ag plus ions. Okay, very interesting. Now, what are these two? These two are called electrodes. One of them may be cathode and the other one anode. Which one is what? We'll see how to decide that. What is this in between? This is very interesting. This is something which is called as salt bridge. What is this salt bridge about? As you can see in the name, it's a bridge and it consists of salts. It is an inverted U-tube. U-tube is a different U-tube also. You are watching us on YouTube also probably, right? But then, this is an actual U-tube, physical U-tube made up of glass usually. You keep it inverted and you keep it filled with a solution. Which solution? The solution is of salts. Often it is KCl or KNO3 or NH4Cl or NH4NO3. Potassium or ammonium, chloride or nitrate. Something of that kind. And what is the role of this? And please note, if you just keep a solution and if you invert it, the solution is going to flow out. So what do? You actually fill it up. You actually fill it up with a gel. You take some gel, agar-agar gel, some kind of a gel, and you mix it with KCl or KNO3 and you fill in this. Even if you have gel, gel may not flow immediately, but gel would ultimately flow. So you put cotton plugs also here. What is cotton plugs? Cotton. You just take some cotton and stuff it so that everything does not tumble down or just slowly flow down. It doesn't happen, right? This is the initial arrangement. And what is the role of this salt bridge? It is a very crucial role. Ions from salt bridge can move into this as well as this vessel and make sure that each solution stays electrically neutral. Oh wow, is that the case? Yes. Is the circuit complete? Of course not. We have to join this, and just for the sake of enjoyment, we will attach a bulb also. Attaching a bulb makes sure that when the current is flowing, we can discover that a current is flowing. And the moment you attach a bulb, you would actually find that it begins to glow. Why? The cell is ready and it is functional. That is why. Okay, and what exactly is happening? So first of all, depict the galvanic cell. First portion is done. This is the galvanic cell. The second portion says, which of these electrodes is negatively charged? Carriers of the current are which ones? And the individual reactions. Now let us discuss them one by one. So first of all, we have to consider what are the reactions which occur at each electrode. Zinc and silver, if you compare them with respect to their positions in electrochemical series or reactivity series, you would discover that zinc has a stronger tendency to give away electrons as compared to silver. So zinc typically would function as anode. If you don't remember, let me repeat. What is anode? The electrode at which oxidation occurs is anode. So please don't remember anode as a positive or negative one. No, wherever oxidation occurs, that is anode. Oxidation is occurring, right? So this is anode. Wow. So this is anode. and wherever reduction occurs, that is cathode. So what happens here? Ag plus takes up electron and gets reduced to Ag. So this has to be cathode. But explain more clearly what is happening. See, the moment you dip a zinc rod in a zinc solution, suddenly zinc atoms become aware, oh my God, we have a solution. Now we are in a swimming pool. Now we are going to jump and we are going to swim and we are going to have fun. So what they do? Zinc atoms, chabak, 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 they actually start jumping and they start moving within the solution. But please remember, zinc metal atoms can't swim. So they leave their own electrons here. Oh my God. So these electrons, yes, they leave excess electrons on this rod. And zinc ions now begin to enter the solution as they like to swim. That's the way of nature. That is their nature. This is the way they function in nature. Right. So now this rod acquires a negative charge with respect to the solution. Right. And what happens at this end? The moment a silver rod is dipped in a solution of silver ions, suddenly, silver atoms are, they are sleepy by nature. They love to sleep. Ag plus ions, the moment they see the opportunity, they say, oh my God, there is a silver rod and we are also silver and they're also silver. So let's go and sleep. And they immediately run towards the rod and oh my God, now we would like to get deposited, we like to stick here. But the problem is, Ag plus ions are ions, they are not atoms. So what they do? They say that if somebody has extra electrons, we will eat your electrons and we become silver and dadam, we are going to stick on the rod and we are just going to sit happily. That is the attitude. Okay, so what happens is silver atoms start moving from solution and they start getting deposited on silver rod. Silver rod becomes thicker and fatter and zinc rod begins to dissolve and it becomes thinner and thinner. Fine. In the process, please note, this solution acquires positive charge and this solution acquires, because cations are lost from it, it acquires a net negative charge, the solution, please. And the rod, this rod becomes positive and this rod becomes negative. Oh wow, so that means in a galvanic cell, cathode is positive with respect to anode, which is negative? Yes. So we have written the individual reactions. We have talked about which electrode is negatively charged, now about the current. That is most crucial. Please remember one rule. Electrons will travel only through metal. They will not flow through water, right? So, if these extra electrons are left out here, they are not very keen to jump in water, they can't swim, electrons can't swim. So, these electrons, ting tadang, ting tadang, ting tadang, ting tadang, they enter and in the process of entering from one end, and this is positively charged and electrons are negatively charged. So, from minus, they tend to flow on this side, which is positive, where electrons are less. And as electrons flow, the bulbs glow. Oh, that's a poem. Yeah, kind of. So as the current is established, the bulb begins to glow. You can say that, oh wow, this is functional. Yes, it is now functional. Isn't that lovely? That's very lovely. And as this is happening, as current is flowing continuously from one end to the other, one end to the other, one end to the other, which is fabulous, fantastic, there is one last problem left. This solution is becoming more and more negative and this solution is becoming more and more positive. And this is where salt bridge kicks in. It says, I have potassium chloride. Say for example, salt bridge has potassium chloride. Now, you will find that anions will start flowing in this direction. And cations within the bridge will start flowing in this direction so that these cations can compensate the charge of extra anions in cathode and these anions can compensate the charge of extra cations in anode. So ions begin to flow within the salt bridge. Yes, not electrons, but the carriers of current in the cell. In wire, the current carriers are electrons. Be very clear, the answer is in 2 sentences. In the external wire, the current carriers are electrons, but in the aqueous solutions and in the salt bridge, the current carriers are cations and anions. Both cations as well as anions. Which cations? All the cations can carry current and all the anions also can carry current. Depends which one is being used at what point of time. That's it. This is the way it happens. So slowly you might imagine that after some time all potassium and chloride ions would have gone away. That's okay. But as time passes, please note zinc ions will also enter. From this end, chloride ions or nitrate ions, whichever ions are the nitrate most of the nitrate ions will also enter. So as they keep on entering, you will not be short of ions in the salt bridge. Initially, salt bridge uses its own ions, and as time passes, ions within the compartments also begin to enter salt bridge because they move slowly, so they take time to enter, and salt bridge is usually never short of ions. This is the construction of a galvanic cell as described here. And all this mechanism which I have told you, very simple, but it is rare that it is clearly communicated everywhere. If students don't understand this clearly, they always have a problem. And I hope you will not have it because you would have understood this by now. In case you have a doubt, repeat this, listen to it once again or twice or thrice till you get a knack of it, and then electrochemistry will be easy.